I'm Alice from the VGS online tutorial series. In a previous video, you have discovered the tab and its advantages. In this video, I will introduce you how to use it. I will explain step by step the basics to analyze a two-dimension pin-joint truss structure. You can see on my screen that I have already drawn a truss structure on Rhino. Two things are important to check. First, the units of your document. It must be in meters. You can see that bottom left of your screen. And secondly, the structure must be isostatic to be easily analyzed. If isn't the case, we'll see in another video how to solve it anyway. Indeed, the tab calculates the axial forces in the bar. The diagram in the Rhino window can be either a direct linear representation of the structure you want to analyze, or a possible static diagram in the material. In my case, I have drawn a simple truss structure in 2 dimensions. Now we can start the VGS part. The model is assembling by the structural model component. We can see that we need 3 data. First the edges, then the loads, and finally the support. First the edges. I will create a curve component and select all the bars in my Rhino document. And I click on Set Multiple Curves. Then I link all the components together. I do the same for the load, but with a point component. Indeed, all the loads must be applied on a node, and I click on Set Multiple Points. Then I create a vector in the direction that I need. I can choose the magnitude of the force with slider component, and in my case I want the A direction. If you want to apply different loads on different nodes, you can just copy all what you need and select other nodes. For example, I want extra load in this case. I change the load and I can select another magnitude for this point. Just pay attention to flatten all the data. To finish, we have to decide of the support of the structure. In other words, in which direction the node can't move. For this exercise in 2 dimensions, the degree of freedom in the direction perpendicular to the plane of my lattice must be blocked for all the nodes. So I will block all the nodes in this direction. Here is the Z. Then our structure needs 3 support directions to be in equilibrium. I decide to put a roller support on the left. I select the node. I set 1 point. I blocked in the A direction. And on the right, I will put pinned support. I do the same, but here I block the 2 directions. I can link the structural model component and flatten all the data. Now the model is ready to be analyzed. It will be evaluated by the Evaluate Equilibrium VGS component, adding model to model. If you want checked if everything is okay, you can connect a panel component, and here you can read that there is no internal mechanism and the structure is statically determined. So everything is okay now. What we want to see are diagrams with internal forces information. The diagrams are assembled with the assemble form diagram. I can connect internal forces with internal forces and external forces with external forces. VGS proposed 2 ways to see the result. First the form diagram and then the force diagram. I will begin with the form diagram. You see that I have chosen where will appear the form diagram. This is possible thanks to the locate diagram component. I select the point in my Rhino window and I create a point component that I connect. I link everything. The diagram will appear thanks to the visual diagram component. You see that I can choose the thickness of the line, the thickness of variable, and the text size. So I will create all the sliders that I need. Now that I have my slider, I can explain you what we are seeing. There is three different colors. It's for the different axial forces. Red is tension and blue compression. If an element has zero internal forces, it will remain in white. And then I can choose the thickness of the bars, because the thicker the bar is, the most important are the internal forces within. Now I can show you the force diagram. For the force diagram, I need the component generate force diagram and a bottom component. I link this with that. For the visualization, I just have to copy here, it's enough. And I select another point that I have chosen that it will be here. I change the point with it. I just have to connect the good component and reset this one. This diagram is perfect to understand which bar is under the most important stress. I can adjust the different size of the text of the bars to see better the diagram. We can say that the bars with the most compression are the F16 and the F15. If I want the numerical value, I can create a panel that I connect with the generate force diagram component. It's easier to read when it's all open. You can see that every information are by node. An easy way to understand which node we have need is to check at the form diagram. Here I see that I need a V7, so I go to the V7 node. I see the E15 and the E16 node, and I see the stress within. It's 4.9 and 4.9 in kilopascal. The compression is negative, so everything is okay, and tension is positive. If I want the bars with the most tension, I can check here, I think, to the V6 node, and I see that the most tension that I have in this truss is 4.53 kilopascal. Now the tutorial is finished. I hope that you enjoy it and it has given you a better understanding of how to use VGS to analyze a 2D truss structure. In a future video, we will see how to solve it if it isn't an isostatic structure. If you want to know how to do that, I invite you to follow us and watch other videos of our VGS series to learn more about structural design with 3D graphics static. See you in the next video!